Hello, everyone. Welcome to Straw Rocketry. I'm Sean. I'm a fourth year bioengineering student from UC Berkeley, and I'll introduce the rest of my team members.
Hi, I'm Wendy. I am a fourth year mechanical engineering student with an aerospace focus at UC Berkeley.
Hi, my name is Celeste. I'm a third-year genetics and plant biology major here at UC Berkeley.
Hi, I'm Michelle. I'm a fourth year studying astrophysics and nuclear engineering. I guess that's it, all of us.
Yes. Wendy, are you ready to share the presentation? Cool.
Hello and welcome to Straw Rocketry.
Yeah, and so we're part of Space Technologies and Rocketry, which is UC Berkeley's premier high-power rocketry team. And so we do competition, research, and outreach. So the main competition we're doing this year is Ezra Intercollegiate Rocket Engineering Competition. And we do research into our custom liquid propulsion, custom flight computers, and custom tubing. And we also do outreach at events such as this one.
So the main portion of rocketry you're working with is propulsion. Propulsion is what makes your rocket go up. And what it does is that a rocket has to push exhaust gas towards the ground so in order to go up. And you can see here that these are the gas that is pushing out. Exhaust gas is formed by burning fuel and oxygen together. And there are two types of fuel that are available. There are solid fuel, which the fuel and oxygen are already mixed together, so it's easy to use and is often used by amateur rocketry, and not really often actual space rockets because solid fuels, while easy to use, they are much less potent. And instead, they usually use liquid fuels such as hydrogen and oxygen. So the liquid fuels are basically hydrogen and oxygen are so cold that they become liquids and not gas. And once they combust, they make steam.
So when we send these rockets up into the air, they are going really, really fast. And so to make sure that the rocket is going up perfectly straight and not doing any weird movements, we usually attach fins to the bottom of the rocket. These fins could be fixed, which means that once we glue them onto the body of the rocket, they stay there. There's no other movement possible. And when they go up, the fins change how the wind hits the bottom of the rocket, so it keeps it going straight up. Another thing we can do is that we could attach active control fins. And those types of fins have pieces on the bottom of the fin that we can change in order to change how the wind hits the bottom of the rocket. And so as the rocket's going up, and if we notice that the rocket's probably not going as straight as we need it to be, we can change how these fins are shaped, and that changes how the rocket goes straight up into the air. Another thing we can do is thrust gimballing, and what that involves is us changing how the propulsion component of the rocket is hitting the ground. So we can have this cone at the bottom of the rocket that has a thrust pointing at an angle to the ground, and that can change whether the rocket's going this way, whether it's going that way, or whether it's going straight up.
Yeah, so sorry. Along with fin controls, like Celeste talked about, there are multiple ways of how amateur rockets deploy and activate different aspects of the rocket itself. So what we do initially is in order to start the rocket, we use an electric igniter to start the engine, so the rocket has enough power or thrust that we call, and it can actually launch from its base. We also, like Celeste talked about, have active fin control to, if the rocket, like she said, ends up moving or tilting in a certain way that we don't want it to, we navigate it the opposite way so it goes straight up. We also have cameras to monitor the trajectories of the rocket while it goes up and while it comes down. And we also have what we call payloads that are experiments that we mount onto the rockets that allow us to experiment with and explore like different scientific concepts in a new environment, which would be like a high altitude environment, which isn't really like our environment and on like the surface of Earth, for example. We also, most importantly, have a parachute on our rockets because that deploy near the peak of the trajectory, or what we call apogee. So it ensures the rocket to come down safely in one piece, so we can take apart the rocket and later on, once it comes down, and see what kind of experiment results we got, and etc.
And rockets also have avionics, which is short for aviation electronics. And so these are sensors or other electric components that allow us to track its course, engine performance, and inform other control systems. So some examples of sensors would be an altimeter, which measures the altitude or height of the rocket relative to the ground, GPS to monitor position, a gyroscope to monitor the orientation, an accelerometer to measure the acceleration, radios to transmit information to and from the ground station to the rocket, as well as a magnetometer, which measures the magnetic field of the Earth. And if you guys have any questions about anything we covered or rockets in general, even just like general things like college, and that's pretty early for you guys to think about college, but if that's the case, you can ask those questions either in the chat or by raising your hand in the participants window. And if you guys don't have any questions, we'll get started with our activity.
Your mission today is to design a simple rocket model using paper and straw. And you will launch your rocket and analyze how design parameters affect launch distance. You can see here that this is an example rocket that we made before. It's very colorful, so you have an opportunity to make your own personalized rockets. Here are the materials. You have to get a paper, optionally a pencil, but way importantly a straw. You can also get a ruler, tape, glue, scissors, and template. Templates are being shared in chat. You can use template to cut out your own rockets. So just going to give you a moment to gather all those materials, and we will explain how to use them in just a moment. I see someone raise your hand. What's your question?
Does it matter with the size of the straw? Because does it have to be fitting tight or what?
They do not have to fit tight. We'll explain more on this later when we get to that step.
Okay.
So you can get as big as you want.
Okay. Does it matter which cutout we use?
So we'll explain that in just a moment.
Okay.
So the first step is to cut the body of the rocket and decorate it, and you can see here. That this template that we use. So there's a little spot here. It's a little common straw size here. Like if you're unsure of the size of your straw, you can just match the straw to the circles to make sure you got the correct size, and you can cut the corresponding body over here. And if you have a bigger straw, you just cut more of those out. You can always go bigger with bigger than your straw size, and that might make taping easier.
Well, the printout that you have from then and I have looks a little bit different actually. Mine only has trees, so I use this one. I have the size this and this. Wait, this and this. So I used the second one or the first one?
I see it didn't show up properly on yours. That's strange. Do you have a straw that you're using right now?
I have this and wait. Here, I have it fits in here.
So that's a pretty big straw. So you don't strictly need a template to do this activity. The template just helps in doing this activity. And if you don't use a template, then the straw will show you how to make your own body.
Oh, okay.
Yeah, so if you don't have a template, you can take either like a pencil or a marker that you just have, and then you can take a piece of paper. Any piece of paper works fine. I just have a piece of scratch paper here. And then you can fold it in half and then cut it to get a half sheet of paper. And so with this half sheet, you can just wrap it around whatever cylindrical object, whether it be a marker or a pencil, and wrap it around like this. And then you're going to use some tape, which I've got right here. And then just tape alongside the edge of your paper cylinder, like so.
Oh, does it match with the length of the
And then so this is going to be essentially your straw. And so what you can do after this is take your second half sheet of paper and wrap this half sheet around your first roll. And then so the second roll, which is going to be larger and
I can't hear you.
fit over your smaller one, this is going to be your rocket, and this is going to be your straw. And so you're also going to tape this one as well. So tape like this. And then you have your straw and your rocket body.
Jonathan, you have another question?
Okay. What?
Do you have another question?
Yes. Does it matter how long the straw is? And so we don't need the straw?
It doesn't matter the length of the straw. As long as you're able to wrap the piece of paper around it, you should be fine.
Oh, so we only need one.
You only need one.
Okay.
And it seems like I think the black one, this black straw you had seemed like the orange circle on the template if you look at it. So maybe that could be the one you want to use.
I don't have an orange circle on the template.
You don't. Interesting.
The yellow one, does it show up yellow for you?
That should be the one.
3 circles.
Oh, do you see black, green, and blue?
No, I see black, yellow, and yellow.
Oh, I see. Okay. How about if you see the black one, try cutting out a size twice the size of the black one, and try maybe doing that. Or if that's a little tricky for you, you can always do what Sean did and try wrapping a piece of paper around the straw and cutting the length.
Okay, let me see. Let me draw a circle. Where's the pencil? Here. Oh.
If you have a template, you can just cut out the template and it will work properly. So once you have your body down, the next step is to glue it. And basically, you have tape. You want the tape to be long. So you might want to cut the tape down a little bit to cut to the time in the middle to make it longer. And what you do is you wrap the paper around the straw, and you can wrap it tight or loose, but make sure that you can tape it airtight, because this ensures that the gas does not escape from the bottom of the rocket. You can see here that I'm taping it along the length of the rocket.
Oh, I don't. Do I have one?
Wait, what step are we on?
So we are on step 2. Once you cut your rocket out, your body out, you can tape it along the length of the straw.
Okay, I need to cut it. So, do I use the first or second or the third line?
So that depends on your straw size. You can see here that on the side there's a bunch of common straw sizes. You can just compare your straw to the circle, and you can cut a corresponding body or fins here. And you can always make your rocket bigger than your straw size.
I have a question. So
We have the paper. Do we wrap it the long way or the short way like he was?
So so I see that you don't want your rocket to be longer than a straw. So you want to wrap it around the short way.
And do I want it not to be this long?
You can, but it's probably easier to cut it out, like cut it slightly more than one loop around the straw.
I have a question. What if your straw size doesn't fit any of them?
If straw size doesn't fit, if your straw size doesn't fit any of them, then it's probably best to use Sean's method of rolling a paper around the straw once or twice, and then cut the appropriate length.
Now you want to tape. Oh, mute it.
So you can see here that I'm still taping my. You can see here that I'm still taping my rocket. Tape it alongside. It's useful to leave a little overlap so that it's easier to tape. And also, you can leave the top a little untaped because we are going to twist it into a nose cone later on. So we are going to move into the next step, which is to. All right, ask your question.
So this video is being recorded. So when are you gonna post the video?
Can you repeat your question, please?
So you're recording this meeting. So when are you gonna post the video?
And I think I'll let one of the moderators answer that.
Okay.
So next step is cut out the fins of rockets. So they are, and tape the fins and fold the fins 90 degrees form cross shape. So you can see here that the template has fins that you cut out. Alternative, you just cut out and then just put it on top of rocket. Alternatively, Sean has a different way to make the fins, to personalize your fins a little bit different than the ones on template.
Yep, so if you have a piece of paper and you want to make your own fins, you can just take your piece of paper and fold it hot dog and hamburger style, and then you can just cut out your own design like this. You have to leave a little room for the tabs so you can actually tape your fins onto the rocket, but then you can just cut your fins into any shape that you want. And just like that. And so what you're left with is two sets of fins that you can tape onto your rocket. So take your rocket, and then at the bottom, you just tape the fins to both sides like this. And then once you tape them down, you can fold them so they create more of a cross shape like this one.
So there's a way to tape your fins. So you basically have to sandwich the fins together, like you sandwich your fins together like this. See, I grabbed the two fins and then just put it like this. You can see that it's being sandwiched. The rocket body is between the fins. And then what you need to do is you take a piece of tape here, and then you can cut to length. Make it a little smaller so that it's easier to tape. You can grab it, and then you tape the top of the rocket. Tape the top. Make sure it's tight. And then once you get the fins on a rocket, you take one fin on each of the fin section and fold it to form a right angle. like take one here and take one here. So this creates a cross shape on the rocket, and then this will help stabilize the rocket in flight. All right, so you get that down, and once you have a tape on you're almost done, but we need one more step before we can actually launch the rocket, and that is we need to close the top of the rocket into a nose cone, and there are two ways to do that. One way is to fold it into a. You see here that it basically twists the tip of the rocket into a nose cone, and the other way is to cut a different piece of paper and then cut it into a circle and then fold it into a cone. You can see here that if it's twisted, it will look like this, and then you close and you tape it around to close it. Alternatively, you can cut out a circle, cut out a small circle. You see here that I'll cut out a very small circle, and you basically cut a line through it, and then you can fold it into a cone like this. Like these are two ways to make a nose cone. And once you close your rocket, you launch it by blowing it into the straw like this. And you should go very far. Hold on, let's go to back my desk. Here we go. You see, this is my rocket. It has big fins and it has a pretty pointy nose cone.
Anybody have any questions? I know that a good number of you may not have been able to get to this step as of now. Any questions about like any step prior to like or attaching the fins or the nose cone and stuff like that?
Anyone? If anyone's done, do you want to show your rocket? Show on the screen.
Cosmo wants to show. Okay, maybe point it upwards. Whoa!
Oh, we went pretty far.
It was fun.
That was really good, yeah.
I see, Sandy, you're making good progress.
I accidentally didn't cut the right size, so I taped two of the pieces together. So I did green and black. I taped them together, and I just got like the body ready. I still need the wing stuff. Fins.
Just take your time, and this is very creative. It's very good the problem solving strategy.
不是已经贴了3个了吗？
还需要贴。
为什么呀？你把声音关掉。
So you're doing an amazing job. I see you're doing an amazing job right there, Vigor. Do you still have any problem with cutting out your rocket? All right. If there's no questions, we have left the lesson plan, entire lesson plan in the PDF. It has steps. There's a lot of steps in there that basically describes how to create your own rockets at home, and there's also a templates attached over there. If you want to teach it to other people, you're free to adapt it to your class or any other purposes.
How did you make the body of the rocket again?
So you remember you can I'm not exactly sure what straw you're using, but you can take the straw. You can you can just make sure you have the right size cut out, and then once you cut out of the size of the body, you fold the paper around the straw, and then you tape it alongside the long side of the body to seal it.
Anybody else have questions?
Yeah, we're almost out of time. So if you haven't finished, you can just follow directions in the from the link that we posted in the chat. And thanks for coming, everyone.
Hey,
We
Greg,
appreciate it.
he had a question. He was raising his hand.
Oh yeah, so you can go.
Making the cone. Can you go over that one more time?
Yeah, so there's two methods of doing it. You can either fold up the top end of your rocket body and then tape that up, or you can cut out a circular piece of paper and then and then cut halfway through the circle, and then you can just wrap it into a cone like this.
Oh, cut halfway. And then let me lay it on. Really.
Thank you for coming.
Like this.
Have a nice day.
Everyone.
Thank you.